Hello, my name is Dr. R. Arpitha, Assistant Professor from Mathematics and Management Sciences, VIGNANA VJYEC. Today I am going to discuss about calculus. In that calculus, the subtopic is differential calculus. Now, let us know what is the definition of derivatives. So, derivative is nothing but whatever the rate of change that occurs of a function with respect to a variable, that is known as a derivative. Or else, if we take, it also gives the slope of the tangent of any curve at a particular point. That is nothing but, suppose if I take, this is an x-axis, okay, this is an y-axis. Now, initially, here some point is there x, and another point I am going to take this one as x plus h. Okay, I am going to take 2 points, x and x plus h. And along the y-axis, I am going to take one point y, another point, this is as y1 and y2. Now, with respect to x, what is the y value? This is the y value. Okay, and as the x changes, that is x plus h, the corresponding y value is this one. Okay, now here if we draw a curve, this is a curve. This is a curve where this is a point, let us say A, and this is a point B. Now, what are the coordinates of A? We can write as x comma y or y1. So, I can write this one as x comma y1, or else I can write this one as a of x comma y1, I can write as f of x. Similarly, the point B is f of x plus h and y2. This is nothing but b of x plus h, and y2 I can write as this one as f of x plus h. Okay, these are the 2 points. Initially, the point is here, and then after some time, the point is x plus h. The distance or the respective of y with respect to x is, so this is the y term. Okay, now A represents the point and B is the represent. Now, what is the derivative? Derivative is nothing but the rate of change. Now, I am going to write limit as h tends to 0, f of x plus h minus f of x by h. Okay. Now, what is the meaning of this one? F of x plus h minus f of x nothing but the change in y terms, that is f of x plus h minus f of x with respect to the change in y. That is the change in y with respect to the change in x as h tends to 0. So, this is the definition of derivative, and it is denoted by f dash of x. Okay. Now, what is the definition of derivative? I am going to take the point x. After some time, another point is x plus h, and the y coordinates with respect to x are y1 and y2. These are the 2 points. And how we are going to define the derivative? Nothing but the change in y. The change in y, that is f of x plus h minus f of x, and the change in x in nothing but derivative. Okay, this is known as, this f dash of x is known as fundamental formula for derivative. So, this is the fundamental formula for derivative, right? Now, with this help of this fundamental formula only, we are going to find the derivative of the functions. Any function, suppose the function may be the e power of x, the function may be the trigonometric functions, or the functions in terms of the some polynomials, whatever they be the function. With the help of this fundamental formula for derivatives, we are able to, we can find the derivation of that given function. And suppose in another way, so I am going to explain a second one, right? Let us know. Suppose initially person is there here, okay? Some person is there, here one person is there, okay? Some person I am saying that is, right, now. So, this is the distance, this is the 1 meter, this is the 2 meters, this is the 3 meters. Initially the person is at this starting point. After 1 second, how much distance is covering? 1 meter. And after another 1 second, is going to cover another 1 meter. And again after 1 second, is going to cover the another 1 meter. So here the position of the person is there. The rate of change of the position of the person with respect to time. The rate of change of position of the person with respect to time is also known as a derivative. Okay. What I have explained here? So here the person is the initial at here beginning place. As long as the time passes, that the position of the person is also changes. Suppose if I take a graph here, okay. Now here 0, 1, 2, 3 and 1, 2, 3. Now how I am going to take the graph? Time with respect to position. Okay. Along the x-axis I am going to take the time. Along the y-axis I am going to take the position. Suppose here time is 1 second, then 2, 3. Now distance is 1 meter, distance is 2 meters, again distance is 3 meters. Okay. Now what I said initially, the person is here. After 1 second, where the position of the person is? This is the position. Okay. Again after another second, the person is here. Then the person is here. Okay. So this is the position we are going to get. Now the rate of change of position of the person with respect to time is nothing but the derivative. So in these two ways we are going to define the same thing. Here I have taken the x values and y values and change of the x with respect to y. This is the derivative. And also if you want to explain physically, that is suppose you are very familiar with velocity. Generally what is meant by velocity? The rate of change of displacement with respect to time. So this thing I have explained with this example, that is the rate of change of position of the person with respect to time. So in physics, so how we are going to explain the velocity? In this way, ds by dt. So these are one of the type of explaining the derivative, and in terms of physics I can write as rate of change of displacement per time is nothing but also velocity. Okay, this is all about the definition of the derivative. And or else it is also going to give the slope of the tangent. Suppose if you are drawing a curve, so if you want to find the slope of the tangent at any point of the curve, so we can find with the help of the derivative. Okay, this is all about the definition of derivative. Definition of derivative is nothing but the change that occurs in a particular variable with respect to another variable is nothing but the derivative. Right. Now find the derivative of x square by using fundamental formula of derivative. You are very familiar that what is the derivative of x square? So directly you can say derivative of x square is nothing but 2x. But from where you are going to get this one 2x? So some basic formula will be there, no? So that one is the basic fundamental formula for derivative is nothing but limit h tends to 0 f of x plus h minus f of x by h. Okay. Now, so any function, whatever the function may be, we can find the derivative by using this fundamental formula of derivative. Now, if you observe here, what is the given function? This is nothing but x square. Fine. Now, f of x plus h, in place of x, what am I having? X plus h whole square. Right. So, expand this one, x square, 2x into h plus h square. Okay. Now, if we substitute in the fundamental formula of derivative, what we are going to get? X square plus 2h into x plus h square minus x square by h. Okay. Now, if you observe here clearly, x square get cancelled. What we are going to get? 2hx plus h square by h. Now, again taking h common, 2x plus some h by h. H get cancelled. Now, see here, as h tends to 0, what we are going to get? 2x plus 0, nothing but 2x. See. Now, are we able to find the derivative of x square? Right. We know very well that derivative of x square is 2x. So, but how we are going to get? Nothing but we are going to find the derivative of x square by using the fundamental formula of derivative. So, if we remember the fundamental formula of derivative, we can find the derivative of any function. Let it be trigonometric function, anything. Okay. Now, suppose let us take the function f of x is some constant. Right. I am taking the function as some constant. I am denoting as some c. Right. Now, if I ask directly, you can say that the derivative of the function, some constant function is 0. Okay, that's fine. Now, let us see how we are going to get that derivative of the function. So, f of x equals c, f of x plus h. What we are going to get? When a function is itself a constant, then if we take the function of x plus h, what we are going to get? Again, we are going to get the constant itself. Okay. Now, what is the formula? Limit h tends to 0, f of x plus h minus f of x by h. Okay. Now, limit h tends to 0. C minus c by h. 0 by something is 0. Now, see how easy is that to find the derivative of a function? So, every time it is no need to mug up the formulas. If you know the basic thing, that is just what is the derivative differentiation and what is the fundamental formula of derivative. If we know this single formula, we can find any function derivative. But it takes us some little bit of time. Okay. So, we got the derivative of f of x is equal to x square, derivative is 2x and the derivative of any constant function is constant. No? Okay, fine. Is it possible to find the derivative of some trigonometric function? Suppose I am going to take f of x equals sin x. Okay. Now, if I ask what is the derivative of sin x, everybody say, okay, sin x is cos x is minus sin x. Okay, fine. No, let us try whether we are going to get this the derivative with the help of this formula. That is, f of x plus h is nothing but sin of x plus h. Okay. Now, derivative formula is f dash of x is nothing but limit h tends to 0, f of x plus h minus f of x by h, right? Limit h tends to 0, nothing but here sin of x plus h minus sin x by h, right? Now, we have reached here. Okay, as h tends to 0, if we substitute here h equals 0, sin x minus sin x is 0, 0 by something is 0. Okay, 0 by. Again, h tends to 0, 0 by 0 is nothing but undetermined form. Okay, here if we substitute the value of h value 0, what we are going to get? The format is the undetermined form. So, now what we have to do? Let us expand the numerator. You know very well that sin c, since sin c minus sin d. What is the formula? We are having 2 cos c plus d by 2, okay, sin c minus d by 2. This is the formula for sum of the terms to the product terms, the trigonometry formulas, okay. So, sin c minus sin d nothing but 2 cos of c plus d by 2, sin of c minus d by 2. Now, so using this formula, limit h tends to 0. Here, what is c? C is nothing but x plus h. And what is d is x. Now, if we substitute it in this formula, what we are going to do? 2 cos x plus h plus x by 2 sin of x plus h minus x by 2 divided by h. Okay. Now, what we are going to get again? If we simplify, limit h tends to 0, 2 cos 2x plus h by 2 sin of h by 2 by h. Okay. Now, we got this one. Now, how to simplify this one? We know very well that, suppose, limit, I am writing here, limit h by 2 tends to 0, sin h by 2, okay. I am taking this 2 down, h by 2, right. Limit h tends to 0, cos of 2x plus h by 2, right. Now, what I am doing? I am taking the terms separately. Limit h by 2 tends to 0, sin h by 2 by h by 2. You know very well that as limit theta tends to 0, sin theta by theta is 1. So, naturally, this term becomes 1. Now, h tends to 0. So, if we substitute in place of h, 0, 2x plus 0 by 2, that is 2x by 2 is cos x. Now, what we are going to get? Cos x. Now, what is the derivative of sin x? Cos x. So, in this way, we are going to find the derivative of any functions. So, first we got the formula of derivative of x square is 2x, derivative of some constant function is 0 and derivative of sin x is cos x. Now, let us generalize the formula. d by dx of x power of n. What is the formula? N into x power of n minus 1. So, here what is the f of x? X power of n. We have to take f of x as x power of n and we will get this formula. Again, d by dx of some constant Derivative of some constant is 0. Now we got that one. D by dx of sin x. What is the answer we are going to get? Cos x. Right? Similarly, d by dx of cos x. We are going to get minus sin x. D by dx of sec x. Sec x, secant x, tan x. D by dx of tan x. Nothing but secant square x. So, in this way, after finding the derivatives of the function, so we can write the generalize every formulas in at one place, and we can easily keep in mind the formulas. Okay. So, the basic thing is how we are going to get all these formulas from the basic fundamental formula. Okay. These are all we are going to derive with the help of that formula. Okay. Now, already we got the sin x derivative and x square and also constant. Now, so one of the application of the derivative. Suppose find. We are going to draw suppose there is a curve is there, and we are going to plot with the help of the given data, we are going to plot a curve. We are going to get the curve. Now, so if you want to know at which place the curve is, at which point the curve is going to be maximum, or at which point the curve is going to be the minimum or maximum and minimum. So for that case, we are going to apply the concept of maximum and minimum with the help of the derivatives. Okay. Now, what is a maximum point? A point where the function attains the greatest value locally or globally. So, naturally, the maximum itself indicate maximum is what is the inner meaning? More, that is greatest. Whether it may be local or globally. Now, minimum is nothing but where the point where the function attains the smallest value. So, we can get a point where the curve will have the smallest value. Okay, this is the definition of maximum and minimum point. Now, how we are going to find a maximum or minimum point of the given function? Okay, suppose let us consider some function f of x is there. We are going to take function f of x. In order to find the maximum minimum, the first thing is we have to find the derivative of the function. That is f dash of x. Okay, first the derivation of function. Then after getting the derivation of function, what we are going to get? F dash of x is 0. So, what is the necessary of doing of this one? F dash of x is equal 0, nothing but when we do this one f dash of x equal 0, we will get here some points. That points are known as stationary points. Okay. Most probably in exams, they will ask that, they will give us some function. They will ask to find the stationary point of the given function. How we are going to find that the stationary point? Whenever the function is given, if you derivative the function, if you find the derivative of that function, and we will get some quadratic equation. So, quadratic equation, anything as a polynomial. So, if we simplify that one, we are going to get the points. The points are known as the stationary points. Okay. Initially, we have taken the function and then we have find the derivative. That derivative we have considered it as 0. If we solve that one derivative part, we are going to get the stationary points. Okay. Then afterwards, what is the step we have to do? We have to find the second derivative, f double dash of x. Okay. Now, after finding the second derivative, here we are having how to find where the function is going to the maximum minimum. Here, suppose we are getting some point. If we substitute the given point in f double dash of x, so what is the point we are going to get? That is stationary point. In that one of the point, if we substitute in the second derivative, if the value is more, that is positive, then we are going to say the function is going to have the minimum. Suppose if the second derivative, it is negative, the function is going to have the maximum. Okay. Whenever we are going to substitute the stationary point in the second derivative, suppose the the second derivative, if it is a positive, then the function is said to have the minimum, and if it is negative, then the function is said to have the maximum. So, suppose sometimes it happens that directly if we substitute the value, we are going to get 0. In that case, we cannot say whether it is going to have the maximum value or minimum. So, this is the procedure how to find the maximum point and minimum point of any given function. So, this is nothing but we can say the application of the derivatives. Right. Now, let us consider one example. Y equals x cube minus 27x plus 108. Okay. Now, y equals to x cube minus 27x plus 108. Let us say this one is y. Okay. This y I can consider this one as f of x or y x cube minus 27x plus 108. Now, okay, this is the given function. Now, how we are going to find? What is the first step? First step is f dash of x. Right. F dash of x is nothing but y dash. Derivative of x cube. That is 3x square minus 27. Derivative of x is 1. Now, 108. Is it some constant, some numerical value? Now only I said what is the derivative of some constant? 0. So, 0. So, this is nothing but 3x square minus 27. Right. This is the first step. Now, what is the second step? In order to get the stationary points, what we have to do? F dash x, we have to equate it as 0. Right. Now, 3x square minus 27 equals to 0. This is nothing but, if you take 3 as common, x square minus 9 equals to 0. Okay. Again, x square minus 9 equals 0. Or we can write this one as x square equals 9. Squaring on both sides, we are going to get x equals to, one point is 3, another point is minus 3. Okay. First, we have taken the function and we got the derivative of that given function. In order to get the stationary point, I have equated the derivative part to 0. So, I got the stationary points. So, let us say this one as a stationary points. Okay. Now, up to here, it's fine. No. But what they're asking, what is the maximum value and minimum value? In order to get the maximum minimum value, let us find the second derivative. First derivative is, let us say this one is 2. 3x square minus 27. If we again derivative is 3, x square nothing but 2x minus derivative some constant is 0. So 6x. Okay. Now, f double dash of x is nothing but 6x. Now, if I say this one as 3, so f double dash of x is 6x. Now, let us substitute. When x equals to 3, what is the value of f double dash of x at 3? That is, f double dash of 3 is nothing but 6 into 3. That is 18. Now, observe here, whenever we are going to substitute the point in the second derivative, what is the value we are going to get? Is it positive or negative? We are going to get positive value. So, then what we can say? Whenever by substituting the value in the second derivative, if we get positive value, now all I said, then the function is going to have minimum value. Okay? The function is going to have minimum value at x equals to 3. Is it clear? Now, similarly, let us see, when x equals to minus 3, let us see f double dash of minus 3, nothing but 6 into minus 3, nothing but minus 18. Now, if we substitute this point minus 3, what is the value we are going to get? It is negative. Okay. So, at x equal minus 3, the function, that is the second derivative of the function, we are going to get negative. What is the meaning of this one? The function is said to be the maximum value at this point x equals to minus 3. Okay. So, we got the point at which the function is going to have the maximum value and minimum value. Now, let us see f of x at x equals to 3. What we have said here? It is going to be minimum at x equals 3. Now, substitute the x equals 3 in the given function. F of 3, nothing but 3 cube. 3 3 is 9, 9 3 is 27. Right. Minus 27 into 3 plus 108. Right. 27 minus 21 plus means 81 plus 108. Right. This is nothing but what we are going to get? 108 plus 27 nothing but 135 minus 81. Okay. What we are going to get? Okay, we are going to get some value. Okay. 19 plus what we are going to get? Plus 35 nothing but 54 value. Okay. This is the value. So, what is the value we are going to get? The total value is 54. At x equals 3, what is the maximum value of the given function is? 54. Similarly, in the same way, if we substitute x equals minus 3, we are going to get the function value, minimum value, that is minus 3 whole cube plus, minus 27 into minus 3 plus 108. What are the value we are going to get? That is said to be the maximum value. So at x equals 3, minimum value. At x equals minus 3, we are going to get the maximum value. So in this way, we are going to find the maximum minimum value of any given function. Okay, first of all, we are going to find the first derivative, and then after we are going to get the stationary points. With the help of the stationary points, we are able to find at what point the function is going to have the minimum value and maximum value. Finally, if we want that particular value, what is that particular value? That is what is the maximum value and minimum value. So after substituting the given function, we are able to find the values. Okay, right. In the same way, here I have considered another problem. Find the maximum minimum value of the function. So I'm going to, first of all, what is the step? F dash of x. Now 2x cube nothing but x cube differentiation is 3x square, nothing but 6x square, minus x square differentiation is 2x, 30x, plus 36. X differentiation nothing but 1, constant is 0. Okay, now what is the derivative we got? F dash of x is nothing but 6x square minus 30x plus 36. Right, fine. Now, so for stationary point, what we have to do? F dash of x is 0. This is nothing but 6x square minus 30x plus 36 equals 0. If we take 6 common, what we are going to get? X square minus 5x plus 6 equals 0. Right? Is it clear? X square minus 5x plus 6 equals 0. So, I have whatever the given function is there, I found the derivative and I equate the derivative to 0. Why I am going to equate the derivative to 0? In order to get the stationary point. If I simplify this one, x square minus 2x minus 3x plus 6, you are very familiar splitting of the given equation. Here I want to find the roots. So x into x minus 2 minus 3 into x minus 2 is nothing equals to 0. Right. So x minus 2, x minus 3. This is nothing but x equals to 2, 3. So, what we are going to call this one as x equals 2, 3, they are nothing but the stationary points. Right. Now, what about the next step? I have to differentiate the function again. So, first derivative I have taken. Now, second derivative, 6. What is the derivative of x square? 2x. Minus 30 into derivative of x is 1. Constant derivative is 0. This is nothing but 12x minus 30. Let us say this one is 2. Now, what is the procedure we are following here? At x equals 2, let us find the function value, second derivative value. 12 into 2 is 24, minus 30, I am going to get minus 6, which is nothing but negative. Now, similarly, at x equals to 3, what I am going to get? F dash of 3 nothing but 12 into 3 minus 30, 36 minus 30 is nothing but 6, which is greater than 0. Right. So, after substituting the point 2, the function, the second derivative is negative, and after substituting the value x equals 3, the second derivative is positive. Now, what we can say here, f of x is having maximum value, right, at x equals to 2. Now, here, what we can say, the function f of x is said to have minimum value, right, at x equals to 3. If it is negative, opposite. So, negative means maximum, positive means minimum. Now, how we are going to find that maximum value, minimum value? By substituting the value in the given function. So, I am writing here directly f of 2. 2 into 2 cube nothing but 2 to the 4, 8 minus 15 into 2 square nothing but 4 plus 36 into 2 plus 10. Okay, this is nothing but 16 minus 15 4 is 60 plus 72 plus 10. So, what we are going to get? 72 plus 10, 82. 82 plus 16 means 80. Okay, so 96 minus 60. 72, 80, 82 plus this one 98 minus 16 nothing but we are going to get 38. Okay, so this is the value. The function is going to have the maximum value at point x equal to, and the maximum value is 38. Similarly, let us see f of 3. F of 3, 2 into 3, 9, 27, right? Minus 15 into 3 3 9 plus 36 into 3 plus 10. So, this is nothing but 54 minus 145. Okay. So, some value we are going to get here 108, some plus 8. We are getting the value. That value is said to be the minimum value at x equals 3. So this is the application of derivative. How we are going to find the maximum minimum value of the given function. For an example, suppose let us say this is there some x-axis and this is some y-axis. Okay, I have drawing the curve. See here this is the curve, this is the beginning point, this is the ending one. So naturally, what is the when the function is going to have the least value here? This is the beginning one. Okay, right. Now when the function is set to be the maximum, this is the maximum value. Okay, here the function is going to have the maximum value. So at which point? So at this point, the function is going to have the minimum value. At this point, the function is going to the maximum value. So graphically speaking means this is the meaning. So whenever we draw a graph, so we are able to find at what point the function is maximum and at what point the function is minimum. The function the function is going to have the maximum minimum at which points. Okay, this is all about the applications of derivative, that is how to find the maximum minimum and basic fundamental formula of the derivatives. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.